Special right triangles. Learning target. I can solve for the measures of the sides of a right triangle using the special right triangle theorems. There are two special right triangles. First is the isosceles right triangle, or also known as the 45-45-90 triangle. From the name itself, these are triangles with interior angles 45 degrees, 45 degrees, and 90 degrees. Now, according to theorem, in an isosceles right triangle, the hypotenuse is square root of 2 times as long as either of the legs. So, for example, here in our illustration, so this is an example of 45-45-90 triangle. Since this is an isosceles, then its legs are congruent, okay, or the measurement of the legs are just equal. And given the leg of an isosceles right triangle, to get the measure of the hypotenuse, just multiply the leg by square root of 2. So again, if the given is the leg of an isosceles right triangle, just multiply it by square root of 2 to get the hypotenuse. But if the given is the hypotenuse and you want to determine the leg, so from hypotenuse, you divide it by square root of 2 to get the measure of the legs. For example, solve for the missing sides of the given right triangle. This is a 45-45-90 triangle. So therefore, this is an isosceles. Legs are congruent. So if the measure of the vertical leg is 12 centimeters, the measure of the horizontal leg is also 12 centimeters. Now, to get the measure of the hypotenuse, just follow the pattern. So given leg, multiply it by square root of 2 to get the hypotenuse. So hypotenuse is equal to leg times square root of 2. Given leg is 12 centimeters times square root of 2. 12 times square root of 2 is 12 square root of 2. So therefore, the measure of the hypotenuse is 12 square root of 2 centimeters. Another example, again this is an 45-45-90 triangle. So we can use the isosceles triangle theorem to solve for the missing sides. Here in this example, the given side is the hypotenuse, which is 5 centimeters. So by using the pattern or by using the theorem, if the given is hypotenuse and to determine the leg, just divide the hypotenuse by square root of 2. So here we have leg is equal to hypotenuse divided by square root of 2. So given measure for hypotenuse is 5 centimeters divided by square root of 2. Okay, we have 5 over square root of 2. So this expression is not yet simplified because there is a radical in the denominator. Now in order to remove the radical, we need to multiply both numerator and denominator by square root of 2 or by the radical itself. Okay, and this process is what we call the rationalization. So multiply 5 times square root of 2 is 5 square root of 2 over square root of 2 times square root of 2 is square root of 4. Simplify, we have 5 square root of 2 over 4 is a perfect square number and its square root is 2. And since there is no common factor between 5 and 2, so this expression therefore is already simplified. The measure of the leg is 5 square root of 2 over 2 centimeters. Okay, second special right triangle is the 30-60-90 triangle. Okay, again from the name itself, these are triangles with interior angles 30 degrees, 60 degrees, and 90 degrees. Now according to theorem, in 30-60-90 triangle, the hypotenuse is twice the shorter leg and the longer leg is square root of 3 times the shorter legs. So here in 30-60-90, we also have pattern. So if the given is the shorter leg, by the way, shorter leg is the side of the triangle opposite to our 30-degree angle. So in this given example, okay, this side is what we call the shorter leg, and the side opposite to our 60-degree angle is the longer leg, and of course the side opposite to our hypotenuse is the longest side, or what we call the hypotenuse. Okay, so to identify shorter and longer legs, just look at the interior angles. So if this side is opposite to 30-degree, therefore it's a shorter leg. If this side opposite to the 60-degree angle, then it is a longer leg. Now let's apply the theorem. So according to theorem, given shorter leg, to determine the measure of the hypotenuse, you just need to multiply the shorter leg by 2. Okay, so this twice shorter leg, or multiply shorter leg by 2. And also, again, if given is the shorter leg and we want to determine the longer leg, okay, just multiply the shorter leg by square root of 3 to get the longer leg. But if the given is the hypotenuse and you want to determine the shorter leg, just reverse the process. So from hypotenuse to shorter leg, you will need to divide the hypotenuse by 2. And also, if the given is the longer leg and you want to determine the shorter leg, again reverse the process, divide by square root of 3. Question: what if I want to solve for the hypotenuse given the longer leg? So we don't have pattern such that given hypotenuse and we want to determine the given longer leg and we want to determine the hypotenuse, and vice versa. There's no such pattern for that. So what we can do is from longer leg, divide it first by square root of 3 to get the shorter leg, and then from the shorter leg multiply by 2 to get the hypotenuse. And vice versa, if the given is the hypotenuse, you solve first for the shorter leg, so divide it by -2 to get the shorter leg, and then multiply by square root of 3 to get the longer leg. For example, solve for the missing sides. Here in the given 30, 60, 90 triangle, the given side is the shorter leg, okay, because this side is opposite to our 30-degree angle. So 2 centimeters is the length of the shorter leg. Now, by using the theorem or by using the pattern, from shorter leg to determine the hypotenuse, just multiply it by 2. So here we have hypotenuse is equal to shorter leg times 2. Okay, shorter leg is 2 centimeters times 2. Hypotenuse is 4 centimeters. Next, again, given shorter leg and then solve for the longer leg, multiply shorter leg by square root of 3. So we have longer leg is equal to shorter leg times square root of 3. Shorter leg again is 2 centimeters times square root of 3. We get 2 square root of 3 centimeters for the longer leg. Another example, again given 30, 60, 90 triangle, the given side is the longer leg because this side is opposite to the 60-degree angle. So this is longer leg. Now let's solve for the shorter and for the hypotenuse. Okay, so let's start with the shorter leg. Again, in our pattern, if the given is the longer leg, and to determine the shorter leg, just divide longer by square root of 3. So we have longer leg divided by square root of 3. Longer leg is 9 over square root of 3. Okay, so we have 9 over square root of 3, and this expression is not yet simplified because again we have radical in the denominator. So multiply both numerator and denominator by square root of 3 to remove the radical. So we have 9 square root of 3 over square root of 3 times square root of 3 square root of 9. We have 9 square root of 3 over square root of 9 is 3 because 9 is a perfect square number. Okay, since there is still a common factor between 9 and 3, so cancel to simplify. So 9 will become 3, 3 in the denominator will become 1. The final answer is 3 square root of 3 over 1 or 3 square root of 3. So this is now the measure of the shorter leg. Next, for the hypotenuse. Okay, to get the hypotenuse, we need the measure of the shorter leg. Okay, we already get the value of the shorter leg, and the pattern is shorter times 2. Okay, to get the hypotenuse. The measure of the shorter leg is 3 square root of 3 times 2. 2 times 3 is 6 square root of 3 centimeters. Okay, so hypotenuse is 6 square root of 3 centimeters. Last example, again 30, 60, 90 triangle. The given side is the hypotenuse. So from hypotenuse, to get the shorter leg, we need to divide it by 2. So shorter is equal to hypotenuse divided by 2. Hypotenuse is 1 divided by 2. This is now the measure of the shorter leg, 1/2 centimeters. And then from the shorter leg, to get the longer leg, multiply it by square root of 3. So longer leg is equal to shorter times square root of 3. Shorter leg is 1/2 times square root of 3. We have square root of 3 over 2 centimeters. So this is now the measure of the longer leg, square root of 3 over 2 centimeters. No need to rationalize because our radical here is in the numerator. So this is already simplified. Thank you for listening.